Good morning. My name is Cooper Brooks. I'm a senior at Westfield High School, and I'm giving my talk today on scientific assumptions. Around the 2nd century AD, at the height of the Roman Empire, there is a mathematician named Ptolemy. Now, not very much is known about Ptolemy's personal life, but his fame has withstood time as he spread his areas of expertise all over science, from music theory to geography. Then in mathematics, he was the first to approximate the value of pi to 3 accurate digits at 377 120ths, or 3.1416 repeating. Then, beyond his life, Ptolemy became the namesake for all sorts of things, from lunar and Martian craters to asteroids to mathematical theorems and graphs. But after all that time and all his work, Ptolemy is most often remembered for just how wrong he was about the geocentric model of the solar system. Now, in Ptolemy's defense, he was not the one to come up with this theory. However, it was Ptolemy's extensively calculated geocentric model that first appeared in his book Almagest that became the leading authority in how the planets orbited until 1543. With the introduction of the heliocentric model by Copernicus. Now, schools put a lot of emphasis on how crazy and self-centered the idea of geocentrism is, but the reality of it is it was in place for over 1,400 years before the heliocentric model was brought up. Ptolemy's hypothesis of the solar system was in place for 1,400 years. Here are just a few things that happened in those 1,400 years. The rise of the Mayan Empire, the life of Muhammad the Prophet, the crowning of Charlemagne, the origin of Arabic numerals, the fall of the Mayan Empire, the Crusades, all 8, the rise of the Second Mayan Empire, the rise of the Mongol Empire, Magna Carta, the fall of the Mongol Empire, the bubonic plague, the invention of the Gutenberg printing press, the fall of the Second Mayan Empire, the European discovery of the Americas, the Protestant Reformation, the first circumnavigation of the globe, and then finally the heliocentric model was introduced. And in all this time, it is not as if Ptolemy's model were foolproof. In fact, one of the biggest things against it was Occam's razor, which most basically states if something sounds crazy, more often than not, it is crazy. And Ptolemy's model was pretty crazy. It went something like this. You start with the Earth in the middle of the solar system, and then the sun and the planets revolve around it. However, there's a problem, as the Earth's seasons are not all the same duration. So let's start over and instead move the Earth a little bit off-center, with a new center called the eccentric, which we'll mark with an X. But there's still problems. When standing on Earth and looking at the night sky and the planets revolving, we see that they do not consistently go in straight lines. In fact, they don't even consistently go in the same direction. Retrograde is an anomaly in which the planets are seen to go back on themselves, or do loop-de-loops in the sky. And Ptolemy and astronomers at the time came up with this idea of epicycles, in which planets have tinier orbits that go along the bigger orbit. In this way, as the epicycle moves along the orbit, the planet can move backwards in the night sky, explaining retrograde. However, there are still problems with this. As Ptolemy found out, the angular momentum of these epicycles were not uniform in relation to the Earth as laws of physics state it should be. It was not even uniform in relation to the eccentric, our new center of the solar system. In fact, Ptolemy hypothesized a third point called the equant, in which these uniform angular momentums were found, which we will mark with this picture of a confused man. Now, that's nice and simple, right? My point is, it was not in the slightest bit simple. And astronomers realized this after the heliocentric model was introduced, as retrograde is naturally explained by the inner planets moving faster than the outer planets. It was so much simpler that Copernicus's model was accepted within 100 years of its introduction, after 1,400 years of Ptolemy's model. Now, we know that Ptolemy and the people at the time were not oblivious. Ptolemy was a very smart man. But the problem with it was the assumptions that they were making. They assumed that the stars were at a fixed distance, that the Earth was in the center of the solar system, and that everything in the universe revolved around it. And these led to false assumptions that led to false conclusions. There's a story along these lines of a famous British philosopher and Nobel Prize winner named Bertrand Russell. Now, he was giving a lecture on logic one day, and how given a false assumption, you can come to any conclusion. When a student raised his hand and said, in that case, given 1 equals 0, prove that you are the Pope. To which Russell immediately responded and said, add 1 to both sides, and you get 2 equals 1. The set that contains the Pope and I has 2 members, but 2 equals 1, so it has 1 member. Therefore, I am the Pope. And as illogical a conclusion as this may sound, the same false assumptions led to false conclusions in our geocentric model. It's being challenged by the idea of irreducible complexity. And we'll analyze this idea through a simple mousetrap. So think from an evolutionary perspective, how might a mousetrap develop through natural selection? Well, first you start with just a wooden block. It has no purpose or function, but through random mutations, this wood block receives a hook. And now it's a wood block with a hook in it. Still no purpose or function. In fact, you can add more and more pieces, and the mousetrap does not have any purpose or function until all the pieces are there. So let me ask you, how does natural selection explain the creation of this system? Incremental evolution does not show any purpose along the way. And a reminder, natural selection is not a directive process at all. In fact, it is random mutations that just thrive in the environment. And when we apply this to real complex systems in biology, the effect increases tenfold. One such system is the translation system in eukaryotic cells, in which there are 3 different kinds of RNA that each fold independently and interact with amino acids and enzymes and translation factors to form basic vital proteins that the cell needs. In fact, many evolutionary biologists agree to the merit of the thought of irreducible complexity just based on this idea that the translation process is not readily explainable by incremental evolution. Without it, eukaryotic cells would not be able to exist, but it's still such a basic function that it's impossible to really understand how incremental evolution leads to it. And so, in the end, as we think about all these things, I'll go back one bit. As we think about all these things, irreducible complexity is most often argued against by the idea of indirect processes. A current example of this is bird feathers are believed to be an indirect process, as they were first developed for warmth and then adapted into flight. However, while this idea cannot be ruled out in irreducible complexity and the translation system such as this, it is important to understand that such a hypothesis is equally speculative with the irreducible complexity and untestable. Therefore, in such a standstill, we should not revert back to the ideas that we hold to normally. We cannot just say it works most of the time. The geocentric model worked most of the time. We cannot just say any idea that shakes up the scientific field should be disregarded, because that just makes us seem ignorant in the end. So I believe in Ptolemy's time, the scientific community should have thought about their own assumptions and challenged them, and instead say, what if the Earth isn't at the center of the solar system? Perhaps we would have gotten to the heliocentric model sooner if they consciously rejected the assumptions they had made. And perhaps we should at the same time say, what if natural selection isn't the best explanation for the development of complex systems? Perhaps we could avoid the same fate and progress sooner. Now, some people may say that the idea of going back on previous conclusions is against progression. However, it is C.S. Lewis who once said, progress is somewhere you want to go. And if we take the wrong path at a fork in the road, it is the first person to make an about turn and go back that is the most progressive. And I believe this idea is one of the hardest things about learning. As a student, we must be able to learn a certain topic and understand it to the point that we are on the same level as our mentors. But then we must be able to go further and challenge the conclusions that were just taught to us. So this can be a very hard process, but I believe the first step that is within reach is to challenge the assumptions that you make on a daily basis and to become more curious about the world for yourself rather than just take the word that others give you. For example, when was the last time you asked or wondered why rain clouds are dark gray when they are made out of clear water? When was the last time that you wondered why only 10% of the human population is left-handed when there's no disadvantage? When was the last time that you wondered why hot water freezes faster than cold water and why cold water boils faster than hot water? These questions do not have easily explainable answers. And so we should wonder about them ourselves rather than just take the conclusions of those before us as law. We should not just assume that the answers and conclusions given to us before are inherently correct. Because in the end, you know what they say about people who assume. Thank you.